Okay, now that we actually know what our vertical misalignment is and how to actually set this up, now we can go ahead and calculate how much shim it's actually going to take to get this thing moved in the direction to where these two flanges line up. All right, so let's go ahead and figure that out. Now, in the last video, we talked a little bit about, hey, this is roughly, well, we're going to put this on, put it back to our mark right here, and at our mark, we are just about 0, okay? And then what we're going to do is we're going to rotate this around. Gravity's going to help me out with this one right there. I'm going to make sure that my mark is lined up right there, and then I'm going to take a measurement, and that's going to be negative 22 thousandths. So yeah, we're at 22 thousandths there of vertical misalignment. So let's go ahead and break out a little bit of math here. So what we're looking for, first of all, is we're looking for a shim ratio, and we're ultimately looking for ST, which is shim thickness. So how far to actually lift up one side of this thing. But in order to be able to do that, we need to figure out a few other things. So we need to figure out SR, which is shim ratio, and we have to do the vertical misalignment. Well, we already know what the vertical misalignment is, and that's 0.022. So now we need the shim ratio. Shim ratio is the diameter of where we measured, okay? So again, I marked with soapstone where it's touching here, and then roughly around where it's touching on the other side, and then I measure in between those two, and I had 3 3/8. Okay? So that is the diameter, the theoretical diameter between where it's touching here and where it's touching here is actually 3 3/8. So that is going to be 3.375. Okay, so now I have the D. Now I need to find the L. What is the L? L's easy. L is the distance where the bolts are. So we want to make sure we're using the right scale. Okay, we're going to go to the center of the bolt to the center of this bolt, and it's likely going to be a nominal dimension. That's 3 inches. Very simple. We have 3 inches. So SR equals 3 divided by 3.375. So let's go ahead and do that. We have 3 divided by 3.375, and that is 0.888 as a repeat end. So SR equals 0.88, and that's the repeat end there. Okay, so now that we have the shim ratio and we have the vertical misalignment, that's very easy. We can go and just continue with this. We'll go equals, and now we're just multiplying this, the shim ratio, by the vertical misalignment, which is 0.022. Okay, so it looks like we have about 19, it's about 19.5 thousand, so 0.0195. Okay, so we're going to just round and say it's about 20 thousandths or so. Now that's where we get into having the shims. Okay, and the beauty of this is we actually have one that is graduated. It's right here on this spine showing us where they are, and we have 20,000 shims. I'm going to read the shim and make sure that it is in fact 20 thousandths, and I'm going to grab 2 of those. Why 2? Well, we're going to be only putting it underneath one side or 2 feet. Okay, so the 2 feet are right here. Now let's go ahead and see what that looks like. We want to be careful with this thing still engaged. We can move it. If we don't choose to move it, that's okay, but we just need to make sure that we're not jostling this motor around too much and causing any damage. So all I'm doing is the motor feet, okay, because that's what I measured and that's what I determined that the actual shim ratio needs to come from. All right, and I want to back these out enough to where I have some play. And if my indicator's moving, I'm not too worried about it. But again, I just don't want to beat this thing up. So, my shim's here. I'm going to try to stay out of the camera. Essentially, I'm going to put them underneath of those bolts. And you can see the bolt is essentially supposed to go right here. So I might want to gently lift up on the front of the motor. I don't know if the camera's picking it up, but the indicator's actually moving as it should be. And I'm going to slide that in on that one, and then I'm going to slide this one in on this one, and then what I'm going to do is I'm going to go ahead and snug this back up. I like to tighten things by hand. It goes a little bit faster generally before I go and put a wrench on it. And you don't actually have to tighten one bolt up all the way before you go around to the other ones. Sometimes it's really a good practice to tighten a little bit on each one as you're going around. That helps things not to move nearly as much and settle in well. It's a good practice on almost everything. All right, so now I have what I consider the appropriate amount of torque on that. So now let's go back and check it. My indicator here is showing something different. I'm not terribly worried about that. I want to make sure that my mark comes back to where it is. Okay, so now that I'm on my mark here, showing I'm about 30 thousandths roughly off. That's really okay. I'm going to move my needle around here to the 0, and then I'm going to repeat this whole process. I'm going to make sure that this is rotating about the same. Drop it down here to which would be the vertical at the bottom. Using my little mirror here, I can look, line up my soapstone mark, and move over here and see that. Okay, so I have negative 2 thousandths, so 0.002. Now, generally speaking, that right there is in the upper limit. However, that is acceptable for misalignment, is 2 thousandths. Okay, so this right here is successfully it's successfully shimmed and adjusted for vertical misalignment. And again, that is, these two things were sitting like this, exaggerated. Now we have them sitting within 2 thousandths like this. So that is a good alignment as far as the vertical alignment for the flange.